Hey boys and girls, this is Miss Taylor, 7th grade math teacher at North Webster Junior High. For today's lesson, we are going to work more with theoretical probability by determining whether a liquid would go when poured into a maze with obstacles. We are going to complete 2 mazes. Each maze has 2 possible rooms the liquid can go to. Each time the liquid hits an obstacle, it is going to split. Sometimes it will only go 2 directions, but other times it will go in 3 directions. Since there are only 2 rooms, you would expect half of the liquid to go in each room. Today's activity is going to help us find out if that really is the case. The yellow parts of the mazes are the paths the liquid can travel. The black parts are walls or obstacles the liquid must travel around. We will be using multiplication of fractions to determine the probability of each path. We will then add fractions to find how much liquid ended up in each room. So let's get started. I'm going to use different colors every time the path splits to help you understand the probability of each path. We will also be using gravity, meaning the liquid can only go in a downward direction. When we finish, we will have found the theoretical probability of each room. So we're going to start with maze number 1. That's this one that looks like a triangle. The liquid can, if poured in, the liquid can either go to the left or right. Since there are only 2 choices, the probability for each direction is 1/2. Going down the right side, the path will split in 3 different directions. It can go here, or it can go here, or it can keep going straight. The probability of each of those paths is 1/3. 1/3 of 1/2 is equal to 1/6. If you multiply 1/2 times 1/3, it equals 1/6. 1/6 will go to the right on the first path. 1/6 will go down the middle path, and 1/6 will keep going straight. The first 1/6 will continue moving downward and end in room Z. So see, it's going to just keep going down like this, and we're going to have 1/6 of our liquid has made it to room Z. The middle 1/6, as it's traveling, hits an obstacle and splits into 2 pieces. Each of those pieces are going to represent a 1/12. This 1/6 that kept going straight, when it gets to here, is going to split off in 2 directions. 1/12 is going to go this direction, leaving it in room Z, and 1/12 is going to fall all the way down to room W. And so right now we have some liquid in each of our 2 rooms. But now we have to continue down the right side. The left side, the left side. And 1/2 of the liquid travels until it gets to this point where it splits off. 1/2 splits off in 2 directions. 1/2 of 1/2 is equal to 1/4. So each of these paths represent 1/4 of the liquid. This 1/4 travels all the way down and ends up in room W. And then this 1/4 travels all the way down and ends up in room Z. Now the left side is now complete. Now we can find the theoretical probability of each room. So we're going to start with room Z. Inside room Z, we have a 1/12 plus a 1/12 plus a 1/12 plus a 1/6 plus a 1/4. In order for you to add fractions, remember you must have a common denominator. The common denominator for 12, 6, and 4 is 12. So I've got 1/12 plus 1/12 plus 1/12 plus 1/6 has to become something over 12. So I multiply it by 2, that becomes a 2/12. And 1/4 has to become something over 12. So I multiply both of those by 3 and it becomes a 3/12. Once you have a common denominator, then you just add the numerators. 1 plus 1 is 2, plus 1 is 3, plus 2 more is 5, plus 3 more is 8 twelfths. 8 twelfths is not in simplest form, and so we divide by 4, and we find that 2/3 of our liquid ended up in room Z. Now, if we did this correctly, 1/3 of our liquid should be in room W, but we're going to check it just to make sure. Inside room W, we have 1/12 and 1/4. Once again, in order to be able to add fractions, you must find a common denominator. So this would be 1/12 plus 3/12, which gives me a total of 4/12. And in simplest form, that is equal to 1/3. So room Z took 2/3 of the liquid. Room W received 1/3 of the liquid. Now that's different from what we thought. We thought because we only had 2 rooms that each one of them would be 1/2. Let's talk about maze number 2. Maze number 2 is going to start off with 3 paths that it can go. Because it starts with 3 paths, each path is 1/3. And we're going to go down this side first. And what I have here is I have my 1/3 is going to travel down until it gets right here and it's going to split. And when my 1/3 splits, it's going to become a 1/6. Okay. This 1/6 is going to travel all the way down and it's going to stop in room Y. It has no more places to split off. This 1/6 is going to travel, but when it gets to here, it's going to split. When it splits here, it becomes 1/12. This 1/12 is going to travel all the way down into room Y. This 1/12 is going to travel into room X. And now we are finished with the right side of our maze. And now we're going to go to the front. Now the front has a lot of splits right here, right off the bat. Because your 1/3 comes out and at first it splits and goes this way. But then your 1/6 is going to split again and go this way. And it's very important that you catch all of these splits in order for the probability to come out correctly. As this 1/6 is traveling, once it gets to here, it's going to make a big split and become a 1/12 and a 1/12. This 1/12 just dumps into room X. This 1/12, however, is going to keep going. When it gets to here, it's going to make a split. 1/12 split becomes a 1/24. 1/24 went into room X. 1/24 ends up in room Y. Okay. Now we come back to here, this 1/12 just drops into room X. This 1/12 is going to travel until it makes the big split. When it splits, it's going to become a 1/24 and a 1/24. This 1/24 drops straight down into room X. This 1/24 is going to travel and stop in room Y. Now we're almost done. Our last one, 1/3, is just going to travel because we're following the laws of gravity. 1/3 has no splits, no obstacles, and so it just dumps right into room Y. Now let's check the theoretical probability. We assumed that because there were only 2 rooms, that half of the liquid would go in room X and half of it would go in room Y. So let's check it and see how that comes out. Inside room X, we have a 1/24, a 1/12, another 1/12, another 1/12, and another 1/24. Remember that in order to add fractions, we have to have a common denominator. Here, our denominator is going to be 24. So I've got 1/24 plus 2/24 plus 2/24 plus 2/24 plus 1/24. Once we have a common denominator, all we have to do is add them up. There's 1, 2, 3, 4, 5, 6, 7, 8. So this equals 8/24. And in simplest form would equal 1/3. So according to this, 1/3 of my liquid went into room X. And if we did it correctly, then that means 2/3 of our liquid will end up in room Y. So let's see what we have in room Y. We have 1/6 plus 1/12 plus 1/24 plus 1/3 plus 1/24. Now again, you have to find a common denominator. In this case, it's going to be 24. So I have 4/24 plus 2/24 plus 1/24 plus 8/24 plus 1/24. And then I add all of those together. That's 4, 5, 6, 7, plus 8 is 15, plus 1 is 16, 24. And if I divide both of those by 8, I end up with 2/3. Now, it might be surprising to you that room Y ended up with most of the liquid on this one. But it's because room X has so many entrances to it, but room Y had the least amount of splits. I hope you enjoyed this activity, and if you have any questions, please feel free to contact me using the Remind app or at melissa.short@websterpsb.org. Also, make sure that you are subscribing to the Charger Strong YouTube channel and watching each of these videos, and making sure that you are doing the assignments that are listed on the resource portal on Webster Parish School Board's website. I hope you all are having a great day, staying safe and healthy, and I hope to see you real soon. Thank you.